The figure shows two large parallel non-conducting sheets with identical positive uniform charge densities and a sphere with a uniform positive volume charge density. Rank the four number points according to the magnitude of the net electric field there, the greatest first. So in this question, they mentioned two non-conducting sheets. As they mentioned in the figure, you can see we have two parallel non-conducting sheets which has the positive charge densities. That means the surface charge density on these two sheets are positive, and we have one more positive charge which was placed between these two plates, right? Now they mentioned four different points. That means point 1, 2, 3, and 4. So in this point or in this location, we have to find which location your electric field will be greater. As we studied from the theory, the formula for electric field calculation is for the point charge, which is E equal to K magnitude of the charge over R square. So here R is the distance from the point where we are going to calculate the electric field. So based on this concept, the point 3 and 4 are closer to the positive charge. That means the distance you can see from point 3 to the charge and from the point 4 to the charge, the distance is d. So that means same distance. So that means here the distance is very closer to the charge. So when the distance will be small, then the electric field strength will be greater. So that means in location 3, which is equal to location 4, the field strength is greater. Now we have to see the second point, which is our second location, and the distance from the point 2 to the positive charge is 2 times of d. So that means now the distance is increased. When the distance is increased, your electrical field strength will be weaker, right? So that means your second value, that means the second highest electric field strength is at second point. Why? Because 3 and 4, the distance is small. That's the reason it takes the first place. And second location, the distance from the point 2 to the charge is 2 times of d. So this is the second highest electric field. So second location is the second rank. Now, when you compare the point 1, we have to apply the Pythagoras theorem. So let's see this diagram here. I'm going to find the distance from charge plus to the point 1 by applying the Pythagoras theorem. So if you see this horizontal line, this distance is 2 times of d, and if you say this distance is y, for example, by applying the Pythagoras theorem, we can easily find this answer, and this distance is y square plus 2d square. And when you substitute the value here, suppose if you assume any value for y and d, and the value for this distance will be greater. That means the distance from the point 1 to the charge positive will be greater when you compare with second point. So that means the last rank is for location 1. So this is the answer for checkpoint 4. That's it. Thank you.